For the last few years, artificial intelligence has operated on a model of internal consumption. You type a prompt, and the system waits passively to generate a block of text or an image. It sits idle until a human tells it exactly what to do. This creates a massive economic bottleneck. Right now, the entire enterprise software industry is capped by the sheer physical limit of humans sitting at desks, manually inputting instructions. While businesses will pay for good information, they will pay a massive premium for actual work. Getting an explanation on how to code a website is helpful, but having an entity independently build, test, and deploy that website while you sleep is incredibly valuable. This is the driving force behind Agentic AI, systems capable of using tools and memory to complete multi-step goals without constant human supervision. Instead of answering a single question, an AI agent takes a complex objective, breaks it down into steps, and executes the entire workflow on its own. To turn AI from a digital chatbot into a tireless 24/7 worker, the hardware infrastructure of the entire world must be completely replaced. Nvidia has shifted its focus from manufacturing individual chips to building the heavy industrial engines of the 21st century. In the last industrial revolution, massive mechanical factories were powered by dynamos that turned water into electricity to mass-produce physical goods. Today, a similar physical infrastructure is being built, but instead of producing steel or textiles, it produces machine intelligence. Nvidia refers to this as the $50 billion AI factory. These are massive, custom-built facilities designed to power thousands of agentic AI systems working simultaneously. When an AI shifts from simply reasoning through a prompt to actively working as an agent, the computing power required jumps by roughly 10,000 times. That sheer volume of calculation makes traditional server racks obsolete, requiring a completely new architectural blueprint. Step inside a modern AI data center, and the physical scale is overwhelming. Acres of floor space are dedicated exclusively to running artificial intelligence. The core engineering problem is that an autonomous AI agent performs wildly different actions within seconds. It searches long-term memory, generates high-resolution images, and reasons through complex logic. That workload is far too complicated for any single type of computer processor to handle efficiently. The solution is disaggregated inference. Inference is an AI answering a specific question. Disaggregation means the system physically breaks apart a user's prompt into tiny, separate computing tasks. The operating system acts like a traffic controller. It routes heavy logic workloads to standard GPUs, while instantly redirecting rapid tasks to dedicated processors, like LPUs, which are designed for high-speed language processing. Building a facility this specialized requires a massive upfront capital expenditure, often $50 billion or more. But that price tag ultimately yields a tenfold increase in computing throughput compared to older server models. By dividing the labor at the hardware level, the system processes information at extraordinary speeds. This extreme hardware specialization drives down the unit cost, allowing machine intelligence to be mass-produced like electricity. Moving these AI systems out of the data center and into physical space introduces a new level of difficulty. A chatbot making a mistake produces a bad essay. A heavy robot making a mistake can cause severe physical damage. Nvidia uses a specific structural framework known as the three computers to safely deploy artificial intelligence into physical space. The first system is the training computer. This is the centralized data center responsible for writing the foundational AI model. The second system is the Omniverse. This is a virtual simulation gym constrained by exact real-world physics. Before a robot moves a physical joint, the AI practices its movements millions of times inside this safe digital sandbox. The third system is the edge computer. This is the localized brain embedded inside the robot. It executes the highly practiced behaviors it learned in the simulation, reacting to the real world in real time. Physical autonomy is the emergent property of this continuous three-stage industrial supply chain. As the cost of inference drops, everyday enterprise workers are gaining access to 10,000 times more compute power than they had just a few years ago. In this environment, companies measure human economic value through the volume of compute tokens a worker successfully deploys. Tokens are the basic units of data, like syllables or characters, that an AI processes to complete a task. Consider a highly paid software engineer earning $500,000 a year. Very soon, corporate management will expect that engineer to consume at least $250,000 worth of AI compute tokens annually. If they spend less, it suggests they are performing the manual labor themselves rather than scaling their output. The most valuable worker in this economy is the director. The person who succeeds will be the one who can successfully orchestrate a massive team of AI agents to execute complex projects instantly. Naturally, the prospect of deploying billions of autonomous AI agents creates widespread anxiety about human obsolescence. To understand how this actually plays out, we can look at the radiology field 10 years ago. When computer vision first emerged, leading experts predicted the technology would completely eliminate the profession of reading medical scans. The technology did exactly what it promised. AI allowed medical scans to be read much faster, which improved hospital efficiency and patient care. But the outcome defied the predictions. Because the friction and cost of reading a scan plummeted, the total volume of medical procedures exploded. With so many more scans being ordered, the demand for human radiologists skyrocketed. As AI factories eliminate the constraints of too hard and takes too long, human creativity and the ability to direct these agents become the only limits on global prosperity.